Hello everyone, in this video I will discuss circles determined by three conditions. Our goal in this lesson are to first determine the equation of a circle given 3 points on the circle. Second is utilize different methods to get the equation of a circle given 3 points on the circle. Now, from elementary geometry, we have learned that circle is determined by 3 points. These 3 points are said to be non-collinear. So when you say non-collinear, that means these 3 points do not lie on the same line. In the previous lesson, we have learned that the general form of the circle takes the form x squared plus y squared plus dx plus ey plus f is equal to 0. Now, we can take this general form if we are to expand the standard form of the equation of a circle, which has the form x minus h squared plus y minus k squared is equal to r squared. If we are to square the binomials x minus h and y minus k, we are going to get x squared plus y squared plus dx plus ey plus f is equal to 0. We see that there are 3 effective constants, which are d, e, and f. In the general form, 3 conditions can be imposed upon them, which will determine a circle, unique or otherwise. Now, let's have the different methods of getting the equation of a circle given the 3 conditions. The first method is circle through 3 points. Now, with the use of the general form of the equation of the circle, x squared plus y squared plus dx plus ey plus f is equal to 0, if we substitute the coordinates of any point, when you say coordinates, that will take the form xy, we get 3 equations in the 3 unknowns, which may be solved simultaneously for d, e, and f. By substituting these values in the general form, we get the equation of the circle. Now, the second method is quite geometric. This method is circles tangent to line. So we will be using the concept of lines and tangents. This method is more geometric. It depends on the geometric fact that the center of the circle is at the intersection of the perpendicular bisectors of segments joining 3 given points. It is sufficient to use only 2 of these perpendicular bisectors. Now, on the next slides, we are going to elaborate on these 2 methods. But for now, let us discuss first method 1. So let's try to elaborate more on method 1. Now, we have this problem. Find an equation of a circle passing through 9, -7, -3, -1, and 6, 2. So these are the 3 points on the circle. So the first step in method 1 is we are to generate 3 equations by substituting the given points on the general equation. The general equation of a circle is given to us as x squared plus y squared plus dx plus ey plus f is equal to 0. So we are to substitute each of these points individually on the general equation of a circle. So let's substitute. So for the first point, we have 9, -7. So substituting 9 to all x in the general equation and -7 to all values of y's on our general equation, we are going to get 9 squared plus -7 squared plus d times 9 plus e times -7 plus f is equal to 0. Okay? And then later on, we are going to simplify that. And then for the second point, -3, -1, our x is -3 and our y is -1. So our general equation becomes -3 squared plus -1 squared plus d times -3 plus e times -1 plus f is equal to 0. And for the last point, which is 6, 2, we will have 6 squared plus 2 squared plus d times 6 plus e times 2 plus f is equal to 0. Now let us try to simplify these equations. For the first point, let's simplify 9 squared plus -7 squared plus d times 9 plus e times -7 plus f is equal to 0. Now, if we are going to square 9 and -7, we'll have 81 plus 49 plus 9 times d. E times -7 is -7e plus f is equal to 0. Next is we are going to add these two constants. 81 plus 49 is 130. Transposing 130 on the right-hand side, we will have 9d minus 7e plus f is equal to -130. And that is our first equation. For the second one, we have on the previous slide, -3 squared plus -1 squared plus d times -3 plus e times -1 plus f is equal to 0. Now, squaring -3 and -1 will have 9 plus 1, and d times -3 becomes -3d minus e plus f is equal to 0. So, adding 9 and 1 will have 10. Transpose that on the right-hand side, we'll have -3d minus e plus f is equal to -10. And that is our second equation. And for the last one, we have 6 squared plus 2 squared plus d times 6 plus e times 2 plus f is equal to 0. So let us square 6 and 2. So that is 6 squared, which is 36, plus 4 plus 6 times d plus 2e plus f is equal to 0. Simplifying that further, we'll have 6d plus 2e plus f is equal to -40. Now, we already have our three equations. We have 9d minus 7e plus f is equal to -130. The second one is -3d minus e plus f is equal to -10. And lastly, we have 6d plus 2e plus f is equal to -40. Now, let's proceed to the second step. Now, on the second step is we are going to subtract equation number 3 from equation number 1 and 2. Now, by doing so, we are going to eliminate one variable, and that is variable f. So, to show you how we subtract equation 3 first from equation 1, so we have here 9d minus 7e plus f is equal to -130. So, that is our first equation. We subtract the third equation, so that is minus the quantity of 6d plus 2e plus f is equal to -40. And that will give you us a difference of 9d minus 6d, that is 3d. Next is -7e minus 2e, that is -9e. Next, f minus f, that is 0, so they will cancel out each other. Next is -130 minus -40. Now remember that when you subtract a negative number, what we'll do is we will add the subtrahend on the minuend. So we'll have -130 plus 40, and that will give you -30. 90. So that is the difference of the first and the third equation. Now let's have the third equation subtracted from the second equation. So we have the second equation, negative 3d minus e plus f is equal to negative 10. And our third equation is 6d plus 2e plus f is equal to negative 40. So by subtracting them again, so we'll have negative 3d minus 6d. We will have negative 9d. Next is negative e minus 2e. So that is negative 3e. And for the third term, we'll have f minus f, that's 0. So they simply cancel out each other. And then negative 10 minus negative 40, so that's plus 40. So negative 10 plus 40, that is 30. Now, we have reduced our equations. Now, if you can observe, on the first three equations, there are three variables. Now, on the fourth and the fifth equation, which we have generated from step 2, we have reduced the equation into two unknown variables. Now, next step is we are going to eliminate one of these variables. So step 3 is solve the given equation simultaneously. Multiply the top equation by 3, then add the equation to eliminate one of the variable. Now the question is, why do we have to multiply the top equation by 3? Now remember that our goal is to eliminate one of the variables. Now if we are to multiply 3 on our fourth equation, each of the coefficients will be multiplied by 3, including the constant. Okay? By doing so, multiplying 3d minus 9e is equal to negative 90 by 3, we will have 9d, because 3 times 3 is 9, and then 3 times negative 9 is negative 27, and 3 times negative 90 is negative 270. Now, copy the second equation, or the fifth equation. So that is negative 90 minus 3e is equal to 30. Now, next step is we are going to add these equations. So adding 9d and negative 9d, that means that they will cancel out each other. Next is negative 27e plus negative 3e. We will have negative 30e, and adding negative 270 and 30, we will have negative 240. Now, to solve for the value of e, is we have to divide both sides by negative 30, okay? And we will have e is equal to 8. Now that we have the value of e, which is 8, we have to solve for the value of d by substituting the value of e to any of the equations on step 2. So what I mean is we will substitute the value of e to equation 4 and equation 5. So you can just choose any of the two. So here we can choose equation number 4. Substituting 8 to 3d minus 9e is equal to 90, we will have 3d minus 9 times 8 is equal to 90, negative 90. So 9 times 8 is negative 72. Next is to solve for 3d, so we transpose negative 72 on the right hand side. So that becomes 3d is equal to negative 90 plus 72. Adding them, we will have negative 18. And then solving for d, dividing both sides by 3. Okay, so we will have d is equal to negative 6. Now that we have the value of e and d, we can now solve for f. Now, where will we substitute our D and E? So our values for D and E will be substituted to any of the first three equations that we got from step 1. Okay? So we can just choose any of the three. So determine the value of F by substituting the value of D and E on any of the equations from step 1. So I have chosen equation number 1. So we have 9D minus 7E plus F is equal to negative 130. So using the values that we have from the previous slide, so we know that D is negative 6 and E is 8. So we'll have 9 times negative 6, that is negative 54. And negative 7 times 8 is negative 56. And then copy 7 and negative 130. So what we'll do is we will transpose all the constants, okay, on the right-hand side, leaving F on the left-hand side. So we'll have F is equal to negative 130. So when we transpose, remember that we changed the sign of the term. So that becomes plus 54 and plus 56. Now adding the three of them, we will have negative 20. So now we already have the value of F, which is negative 20. So substitute the value of D, E, and F on the general form of the equation of a circle to get the equation of the circle passing through 9, negative 7, negative 3, negative 1, and 6, 2, we will have, okay, so from the general equation, we substitute D, which is negative 6, E, which is 8, and F, which is negative 20. And we will have x squared plus y squared minus 6x plus 8y minus 20 is equal to 0. Therefore, the equation of the circle is x squared plus y squared minus 6x plus 8y minus 20 is equal to 0. And that is how you use the first method in determining the equation of the circle given three conditions. Now let us proceed to method 2. So in method 2 is we are going to make use of geometric concepts. Okay? So using the same problem, find the equation of the circle passing through 9, negative 7, negative 3, negative 1, and 6, 2 is we are going to determine the general form of the equation of the circle, which passes through these points. So step 1 is we are to plot these points on the Cartesian plane and show an illustration of our circle. Okay? Next is we are going to make a chord out of two chosen points on the given. So here, the two chords that we have is negative 3, negative 1 going to 6, 2. And the other chord is 6, 2 going to 9, negative 7. The first step is to determine the midpoint between any of these 2 points. Okay? So, first is we have here midpoint L. Second is we have this midpoint N. So, first is for the midpoint of line N. So, to get the midpoint, remember that simply we'll just have to get the average of the values of x and the average of the values of y. So, for our x sub 1, we can just choose any of values of x from the given points. So we have 6 plus 9 over 2. And for the y, we'll have 2 plus negative 7 over 2. So simplifying that, we will get 15 over 2 and negative 5 over 2. And for the other line, other chord, okay, we'll have x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. So same formula. Now, the values of x are negative 3 and 6, and the values of y are negative 1 and positive 2. So we'll have 6 plus negative 3 over 2, and the other is 2 plus negative 1 over 2. So adding the values in the numerator, we'll have 3 halves and 1 half. So these are the coordinates of our midpoint. Next step is we are going to determine the slope of the line N and line L. Okay? So we are going to determine the slope of our chords. Okay? So first is we are going to focus on these lines. Okay? So to get the slope, we know that the formula of the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So substituting the values from the given points, 6, 2, and 9, negative 7, will have negative 7 minus 2 over 9 minus 6. Simplifying that, will have negative 9 over 3, or simply negative 3. And for the second line, for line L, the points are negative 3, negative 1, and 6, 2. So same formula, substitute the values of y. So we have 2 minus negative 1 over 6 minus negative 3. Now we know that when we subtract a negative number, we are going to do the opposite operation. So you'll have 2 plus 1, so that's 3. 6 plus 3, that is 9. 3 over 9, both of them are divisible by 3. So we can write the fraction in a simpler form, and that is 1/3. Now that we have the slope of the two lines, let's proceed to step 3. Now, for step 3, we are going to determine the equation of the perpendicular bisectors. Now, the perpendicular bisectors are shown on our illustration as broken lines. Okay? So, perpendicular bisectors, by definition, these are just basically lines that are formed which divides a line into two equal segments. Now, these perpendicular bisectors create a 90-degree angle with respect to the chords. So, to get the equation of the perpendicular bisector, is we are going to make use of the value of the midpoint, which we have taken earlier, and the negative reciprocal of the slopes of the chords. Okay? So, first is let's determine the equation of the perpendicular bisector of N. So again, earlier, the slope of this line is M is equal to negative 3. Now, if we take the negative reciprocal of the value of its slope, that means that the slope of this perpendicular bisector is 1/3. Okay? So that's why our M sub N is equal to 1/3. And our given point is 15/2, negative 5/2. So let's substitute these values on our point slope form of the equation of the line. So we have y minus negative 5/2 is equal to 1/3 times x minus 15/2. So simplifying it, you'll have y plus 5/2 is equal to, distributing 1/3 to x and 15/2. So we'll have 1/3 x is equal to 15/6. Next is Simplifying 15 over 6, both of them are divisible by 3. That becomes negative 5 over 2. And this one, 5 over 2 on the left, will be transposed on the right, so that becomes negative 5 over 2. And in the same way, these 1/3 x will be transposed on the left-hand side. That's why it becomes negative 1/3 x. So what we have here is negative 1/3 x plus y is equal to negative 5 over 2 minus 5 over 2. And then adding the constants, we will have negative 10 over 2. Now eliminating the denominators by finding the LCM of 3 and 2, we have to multiply the whole equation by 6. So that means we'll have 6 times negative 1/3 x plus y is equal to negative 10 over 2. Simplifying that, we'll have 6 times negative 1/3, so that's 6 times 1, so that's 6 divided by 3, so you have negative 2x plus 6 times y is 6y is equal to 6 times 10 is 60 divided by 2, so that's negative 30. And then all of the coefficients are divisible by 2, so we can simplify it down to x minus 3y is equal to 15. Next is we have to get the equation of the perpendicular bisector to line L. So earlier, the slope of line L is 1/3. Okay, so the slope of this line is 1/3. So the negative reciprocal of 1/3 is negative 3. So therefore, to get the equation of the perpendicular bisector, our values of m and the point are, m is negative 3 and the point is 3 over 2 and 1/2. Now using the point slope form for finding the equation of a line, we'll have y sub 2 minus y sub 1 is equal to m times x sub 2 minus x sub 1. We'll have y minus 1/2, the value of y is equal to negative 3 times the quantity of x minus 3/2. Next is we have to distribute negative 3 inside the parenthesis, so we will have y minus 1/2 is equal to negative 3x plus negative 3 and then negative 3, so that's plus 9 over 2. Next is we transpose all the constants on the right hand side and all the terms containing variables on the left. So on the right, we'll have 9 over 2 plus 1 over 2. That is 10 over 2. And simplifying 10 over 2, we'll have 5. So therefore, the equation of the perpendicular bisector to line L is 3x plus y is equal to 5. This one is 3x plus y is equal to 5. Now here, on step 4, since we have the equation of the two bisectors, and we know that the intersection, meaning these two bisectors meet at the center of the circle, now we have to solve the equation simultaneously. Okay? So our equations are x minus 3y is equal to 15, and the other is 3x plus y is equal to 5. So doing the same process as we did on method 1, okay, we will find a way to eliminate one of these two variables. So what we'll do is we will multiply the bottom equation by 3 to eliminate y, because the value of the coefficient of y on the first equation is negative 3. The coefficient on the second equation must be of opposite sign but equal in value, so that should be positive 3. So to do that, we have to multiply the second equation by 3. So that becomes, so copy the first equation, which is x minus 3y is equal to 15. The second equation, we multiply by 3. So that becomes 9x plus 3y is equal to 15. So next is we add them. So that leads you to x plus 9x is equal to 10x. This will cancel out. 15 plus 15 is 30. Solving for x, we'll have x is equal to 3. Now that we have x is equal to 3, we will solve for the value of y by substituting 3 to any of the two equations of the bisector. So you have the first, which is x minus 3y is equal to 15. So substitute the value of x, okay, which is 3. So we'll have 3 minus 3y is equal to 15. So transposing 3 on the right hand side, we'll have 15 minus 3, and that becomes negative 3y is equal to 12. Dividing both sides by 3, we'll have y is equal to negative 4. So now we know the coordinates of the center, which is 3 and negative 4. Next is, we have to solve for the radius of the circle. Now, to solve for the radius of the circle, we are to make use of the coordinates of the center, which is 3 and negative 4, and any of these 3 points. So here, I have chosen 6, 2. So using the formula for radius, okay, or you can make use of the distance formula. So r is equal to the square root of, you'll have 6 minus 3 squared plus 2 minus negative 4 squared. So simplifying it further, we'll have 6 minus 3 is positive 3. 2 minus negative 4, you'll have 2 plus 4, so that's 6. So squaring both of them, we'll have 9 plus 36. 9 plus 36 is square root of 45, or basically that is 3 square root of 5. So now we already have the center and the radius. So we can substitute these values on the standard equation of the circle. So on step 6, substitute the center and radius to the standard form of an equation of a circle. So the standard equation is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So substituting the value of the center, which is 3 for x and negative 4 for y, and our radius, which is 3 squared of 5. So we'll have x minus 3 quantity squared plus quantity of y plus 4 quantity squared is equal to, here we'll have square of 5 is 5, square of 3 is 9, so 9 times 5, that is 45. So this is the standard equation of the equation of the circle. But what is asked is to show the equation of the circle in general form. Therefore, it is necessary to expand these two binomials. So expand the square of the binomial to get the general form. We'll have, so for x minus 3 squared, we'll have x squared minus 6x plus 9. And for y plus 4 squared, we'll have y squared plus 8y plus 16. And then copy is equal to 45. So adding all the constants on the left-hand side, so we transpose 45 on the left. So we'll have x squared plus y squared minus 6x plus 8y plus 9 plus 16 minus 45 is equal to 0. We'll have x squared plus y squared minus 6x plus 8y minus 20 is equal to 0. And that is how we use the second method in finding the equation of the circle given 3 points on the circle. And that would be all for this video. I'll see you on the next one. Goodbye!